Hi, this is Service Pro with the Dr. Vax channel. And as we approach the holiday season, it's just a few days before Thanksgiving, we begin to think about family. In my case, I'm blessed to have 4 grown children and a gaggle of grandchildren. I have a grandson out of state whose father has taught him to play chess. And we play chess online, and this last Sunday, he beat me. Now, that wouldn't be all that surprising, except that he's in kindergarten. And clearly, his skills are advancing much more rapidly than mine. So I dug out my chess books, and I'm beginning to remember things that I probably never really knew. But it also gave me a wonderful idea. I'm always looking for new things to design in FreeCAD that I can use to teach techniques. Right now, I want to teach people how to combine multiple workbenches when building a single project, and how to truly make a design that's parametric, where parameters drive the design. So this is the first of what will probably be a number of videos about designing a chess set in FreeCAD. Today, we're going to design a pawn. Here's a little tiny one from a travel set. Here's quite a bit bigger one that I designed in FreeCAD. And you'll notice that this one, I only printed half of it. I'll explain why shortly. So stay tuned and let's learn something together. Now, before we get started with this video, since this is a video that's going to be a series of videos about creating all the chess pieces and the board for this travel chess set, if you want to make sure you know about the future videos, subscribe to the channel and click on the bell. And then you'll have an opportunity to be notified by YouTube automatically when the next video is available. If this is the very first FreeCAD video you're watching, it's the wrong one. Instead, look up in the corner and you'll see there's a playlist linked there with a whole bunch of FreeCAD videos. You really should watch the one about installing FreeCAD first, because it'll show you how to configure it so it looks like the version you're seeing from me on the screen. I will talk about a couple tips related to that in this video. In addition, then there's a FreeCAD for Beginners series, part 1, 2, and 3. Watch those next. Then you can watch any of the other videos in the series in any order. So let's go to FreeCAD version 0.19. But there's a problem. The problem is if you recently upgraded to macOS Big Sur, 0.19 won't run anymore. The standard release on the release page is not working. It's probably an incompatibility with graphic drivers that Apple tends to mess with a bit on each release, but I've discovered a way to install 0.19 on Big Sur, and I'll provide you a link here on the screen to the Dr. Vax website, to the blog where you can find those instructions. I'll also put the link down below in the description. Okay, let's go to the screen now. We're in FreeCAD, and the first thing I'm going to do is go to Preferences. And the reason I'm going to do this is the most common comment I get on both the comment sections on YouTube, on forum.drvax.com, which is the discussion group for my viewers, completely free, is my version of FreeCAD doesn't look like what you're showing me on the screen. So just to refresh your memory, I'm going to go to the Preferences panel and click on Reset, Yes. So now my version of FreeCAD is the way it should come from the factory, so to speak. Now I'm going to go back to Preferences and make a couple quick changes. The first is I'm going to go over to Display, and I'm going to change the marker size to the biggest size they support, 15 pixels. That'll make it easier to line up points on your screen. Now I'm going to exit from the preference window, and I'm going to pull up the part design window. And now when I'm in the part design workbench is the proper term, if I go to preferences, I'll see there's an additional set of preferences listed here. So I'm going to go to the preference for Sketcher that's now listed, go to display, and I'm going to make the font size, a little bit bigger. We'll make that 40 instead of 15 or 20, whatever it was. Click apply and OK. That'll make it easier for you to see what I'm doing on the screen. Now today, in designing a pawn, we're going to design the profile. We're going to draw the profile. We're going to then rotate it around an axis to get this shape. We're going to design the bottom half. I'll show you a picture on the screen now, a bigger picture. The bottom half first with the rotation. Then we're going to use the part workbench. The bottom half will be designed with the part design workbench to add the bulb on the top. In addition, the way we're going to design this, we'll be able to go to another tab, the Spreadsheet workbench tab, and change a single number to scale this up or down. So let's get started in part design. So I'm in part design. I'm going to click on create a new document. I could do file, new also. I'm going to create a body, create a sketch. Once again, all things you should already know about if you're watching this video. If not, go to the videos up in the corner and start with the basic videos. And we're going to model on the XZ axis because we're going to rotate it along the vertical axis. So it'll be easier to create a profile around this axis. We're going to click OK. Now I'm going to go and move this over a little bit. I'm actually going to zoom in quite a bit. So this is a bit bigger. And I'm going to start by drawing my base. So I'm going to click on line. I'm going to hover over the red axis center origin dot until it turns white, and that's a little tricky to do sometimes. So let me show you another trick. Instead of hovering over that, I'm just going to draw a line here by left-clicking once, waiting until the constraints show that it's a horizontal line, left-clicking a second time, and then right-clicking. So I have a line here, but I really want this line to start on the origin. So I'm going to select these 2 points, and I'm going to click on the constraint to create a coincident constraint between these 2 points. Bam, now it's on the origin. So if you have trouble lining up with a dot, don't worry about it. With a point, just draw your shape, then find a point on the shape, a point you want to line up with, and add a constraint. Now, this is going to be a really critical dimension because I'm going to base all the dimensions in this drawing on this dimension. So instead of putting a number in, I want to put a parameter in. The way I'm going to create my parameters is I'm going to go to the Spreadsheet workbench and click on this item in the corner which looks like a spreadsheet to create a new spreadsheet. You can only have one workbench active at a time, so let's close that original sketch. Now click on that spreadsheet and it will create a new workbench. Now this works like Excel or Google Sheets, but it's a little fussier. You have to be a little more precise. It doesn't have all the formulas, but I'll show you some basic stuff. Now, if we look at a chessboard is perfectly square, divided into perfect squares. There are 8 squares across, 8 squares down. So if I know this dimension, I divide it by 8, I know how big a square is. So let's put a label here, and we'll say this is the chessboard. Let's put a second label here, and this label we'll call square. And then we're going to want a dimension for the pawn. So we'll call this one pawn. Now my chessboard, for argument's sake, let's make it about 150 millimeters. That'll print nicely, a travel size. It'll fit on my printers. That means that the chest square is B1. And very important, you have to use capital letters. It doesn't recognize lowercase letters. Divided by 8, 18.75. Now, there are actually rules in chess about the size of the pieces. I don't remember exactly, but there is a rule about the amount of space the base of a piece should take in a square. I think it's about 75% or so. So we're going to go with that. So I can say here that a pawn is equal to B2 times 0.75. Now we have all of our dimensions. But these dimensions are not easily seeable by our model. In order to make them easily seeable by our model, we go to a dimension, we click on Properties, click on Alias, and we give it a name there. Now, once we have a dimension with an alias, that element, that cell in the spreadsheet will turn yellow. To see that this is actually working, let's go to the one called Square and give it an alias called Square. And now I'm going to click on this formula here, and I'm going to change it to be square times 0.75, because aliases can also be used in your spreadsheet. Okay, so I have this spreadsheet now. I don't actually have to close it. Spreadsheets can be left open. I'm going to go back to my model. I'm going to go to the sketch, double click on it, and now let's give a dimension to the base of this pawn. Okay, I'm going to click on my line segment, then click on horizontal dimension. We'll see right now it's 49. That's not what we want. And here I'm going to click on the little FX in the corner and then click in this box. You have to click in the box for it to be active. And now I can type in spreadsheet. It's capital S dot, and I can start typing the names of the aliases, and we can see pawn is there. So it'd be 14 millimeters is what that calculated to. Now, we have to remember, though, that this is going to rotate around. So if I make it 14 millimeters, it's going to actually end up 28 because it's going to be twice. That's going to be a radius, not a diameter. So we're going to divide that by 2 and click OK. Okay, now we can zoom in a bit here and we can scroll in and we can say we have that dimension. Now, let's add the axis we're going to rotate around, and let's add this top shelf here and then the line coming down, and then we'll add in the curve. Okay, so let's add another line segment. Click here. I'm going to hover over this dot till it turns white, and because it's nice and big, I can get there, and that looks about right. Then I'm going to hover over this point, and the top looks like about that. Hover over this point, bring that back to about there. So we've effectively drawn part of the outline of our pawn. Now we need to draw a curve. So for the curve, we're going to use a different tool called the B-spline tool. And if you click here, you can see B-spline with control points. And there's another alternative for periodic B-spline. We're going to use B-spline with control points. I'm going to hover over this dot, click once, and then in essence, using straight lines, more or less model this curve with straight lines. So this goes out about like, let's say there, and then it goes out, let's say there, and then we'll connect to there. Now I'm going to right click. I was left clicking, and right click a second time to deactivate the tool. The first time converts the line segments into a B-spline. The second time deactivates the tool. Now let's sort of move these around. And the way you control these is you take these rings and you can just sort of move them around. And let me point out one thing right away. You don't want any of your curves. See how this curve on the screen here overlaps? That will not work with a revolve. So we have to keep this here about like that. I think I'm going to make this segment a little shorter, about like that. And that looks more or less like the base of our pawn. Now, let's go ahead and find a constraint for this height. We'll see the height here is almost 17 millimeters, the way I drew it with my eye. So we'll use that 17 as a goal, but we want that now to be a multiple of the base. So let's go here and put in spreadsheet dot pawn. We'll see that's 14 times, let's say 1.2, and we'll make it 1.3, a little bit bigger. So now if I change the pawn number in the spreadsheet, it's going to change both of these. Okay, so now I have the base and the height both controlled by parameters. But something I have to be careful about. If I pull this height all the way down and I leave this curve where it is, it's going to overlap this axis. And remember, overlapping surfaces cannot be used for a revolve. So that will cause an error to occur. So we're going to have to also define some other things. When I make this taller or shorter, I want to define where this point is also. So let me take that point and select this point with a command click. It would be control click on a PC. And let's put a vertical dimension on it. Should be about 14 to make it look the way it looks right now in my diagram. And so now I could say in here, spreadsheet dot pawn, and that is almost exactly 14. So that sort of makes sense. And let's move this a little bit. Let's define this surface right here. So I'm going to put a dimension on that also. And that's about 10. So this is spreadsheet dot pawn times, let's say, times 0.75. Okay, so what you can see here is I'm slowly defining all of these points. Now, any of these control points are actually defined by a vertical position and a horizontal position. So if I want to truly define this properly, I also have to add horizontal dimensions to all of these. We'll add a horizontal dimension to this one. And that would be spreadsheet dot pawn, oops, times, let's say, 1.2. Okay, so we've more or less defined these. So we can close this now, and we have a shape. We can make sure our shape is selected, go to tasks, and we have to make sure our workbench that's currently selected is part design. So if you select your sketch, you go to tasks, the workbench that was selected was before still spreadsheet. So the tasks displayed were related to spreadsheet. So it's a little bit tricky. You do have to have the proper workbench selected if you want tasks to represent that workbench. We're going to click on Revolve. And you can see here we have a relatively ugly looking pawn. It's not quite what we're looking for yet. Let's look at it from this dimension. We clearly want this to be a little taller. So how would we do that? We click OK. We're going to go back to our model. And under the revolution, we're going to click on the arrow to expand it and double click on sketch. And this dimension here, we'll move this over so we can see it. This dimension here needs to be taller. So we're going to double click. We're going to look at our formula. And instead of making it 1.3, we're going to make this 1.75 and see how this looks. Okay, so that probably helped, but this line segment right here probably needs to move. And for that to move, since we have a constraint here, I'm going to first delete this constraint. Then I should be able to move that up. And let's not add a new constraint yet. Let's see how it looks. So I'm going to close this. And that actually looks pretty good now. So now let me take and add in a new constraint. And this time I'm going to do it by adding in a constraint on that angled line as maybe a better way to do this. So that's relative to the spreadsheet, to pawn. Coming up is 14, that was 7. So let's say times 0.5. So we'll make that part of this shape, this little angle here, about half the base. Okay. And let's take and move this out so we can see it. That looks pretty good. Let's close that up. Okay, now, once we get all of these dimensions defined as relative to our starting dimension, to the pawn base size, then I can go into the spreadsheet, I can just change one of these. So instead of 150, if I make this 200, and I go back here, you'll see it's taller. Let's make it even bigger. We'll make it 300. Tab out of that cell, go back here. Now at 300, you'll see there's some dimensions that I haven't constrained yet. Because remember that to make this work perfectly, I need to put 2 dimensions on each control point. I need a fully constrained diagram, a fully constrained sketch. And this one is not. So we're going to put this back at 150 for right now, just to show you that it will change back. Now to show you what a fully constrained model would look like, let me take here and do an open of one that I took the time to fully constrain. Here's one here, and this one even has the ball on top, and we're going to get to that in a minute. So if I go to this one, and then down here in this one I have a spreadsheet. I go to this spreadsheet. Let's make this, let's say 300. Then I go back to this one, and you'll see that scaled perfectly. And we're going to go to this one, and we're going to make it 150. And it's scaled down perfectly. So by putting constraints on every parameter, and let's look at that here, you'll see that this diagram is green. The reason it's completely green is, as you know from other tutorials, it's fully constrained. So if you have a fully constrained sketch and you have a parameter outside of it driving it all in the spreadsheet, then you can build a model that by just changing a number, you can change the size overall of your model. Now I could have, in that spreadsheet, put a width and a height and done all the algebra in the spreadsheet. That would be an alternative way. 6 of one, half dozen the other. Okay, how to get this sphere on the top here? Where's that come from? Well, let's close this all. I'm not going to save that. Let's go back to this one. It's a little bit different than that one. I'm going to make one change here. I'm going to make this dimension a little bit smaller. So let's go to this formula and let's make this 0.6. And let's see how this looks now. No, that's not quite right. Let's make it 0.65. And I'm actually going to pull this point in a little bit. And it's not fully dimensioned, so it doesn't really matter. And that looks pretty good. Now, I have a body. I want to add another body on top. I have to create another body. So I can create another body in Part Design, or I can go to another tool that creates bodies standalone. I'm going to go to the Part Workbench. Now the Part Workbench, from my point of view, feels like Tinkercad that's, running at 200%, a beefed up version of Tinkercad. And you'll see it has all the sort of primitives that you would see in Tinkercad. I'm just dragging these items around. And remember, if you don't see an item on the screen, you can just drag it around to get it to where you want. I'm going to just create a sphere. So it created a sphere down here. And now I can take and I can define the size of that sphere parametrically. How? I'm going to click on the little formula editor icon. I'm going to go on here, and that spreadsheet is shared across all of the workbenches. So I'm going to click on Workbench, Pawn, and let's initially try making it the same size as the base. Okay, and click out of here. Oh, that's too big because we're going to have to make it half the size of the base, I think. So let's say pawn times 0.5, because once again, it's a radius, not a diameter. So the base number is the diameter, so we need it to be half that size. There we go. Okay, let's look at our sphere now on the screen, and we'll see it's at the bottom. We want it on the top. Now, in a CAD program, in a parametric CAD program, you can't really just drag things around. There is the ability to do that in the draft workbench we'll cover in another tutorial. But the better way to do it is parametrically, to position it where you want it. So I'm going to make sure I have the sphere selected here, and I'm going to go to Position and click on X. Now I could just type in a number here and move it with that. That's obviously much too high. So let's move it up 10, or I could move it up 20, or I could move it up 40. That's a little too high. 30. So I could move it that way, but a better way is to use a formula. So let's make it parametric to the same spreadsheet formulas we used before. So I'm going to say spreadsheet dot pawn, and let's say times 6. That looks a little too high. Let's say times 5, and then click out of that cell. Whoops, way too high. And the reason is that, remember, the base, the number in the spreadsheet is the diameter. We want to move it up by a multiple of the radius. So in essence, I have to divide that by 2. So let's say times 2.5. That's pretty close. Let's try times 2. And that's pretty close. I think I'd like it actually a bit higher, because we want it to be connected, but we want it a bit higher. So we'll just play with this a little bit, times 2.2. Click out of that cell. And let's see if that's still touching. Yeah, it still looks like it's touching. And so I think we are there. We've now created a pawn. So now that we've created this pawn and it's parametric, we probably want to make it a single object. So I'm going to select the first body, Command and select the second body. I'm going to go over to this icon right here and create a union. So now it's one item. That's called a fusion here. You can still see everything down below it is still here, but we can take this single item and do a File, Export, and we're going to export it as an STL file so we can open it in a slicer. So I'm going to select STL. I'm going to save this as pawn for Cura. Save it. Now let's open up our slicer and see if it slices properly. So I'm going to go to Cura. And you'll see here I'm on Cura version 4.7.1. There's a 4.8 out. There's some chatter on the internet about 4.0 having a bug about cooling fans. I haven't installed it yet until I have time to research that. So I'm going to skip that. Let's go and see if I can move this over a little so that we can see it a little better. I'm going to open up the pawn for Cura that I just created. Wow, that looks pretty good. Little bit of an overhang here. But I could solve that one of two ways. I could move the ball down a little bit, or I could just see if it'll actually print. There's a little overhang on the bottom. That may or may not be a problem, but we could slice this now. We'll see that this will print in 13 minutes because we're printing a relatively small pawn that's going to fit on a board about this size, and we are ready to go. Well, folks, I hope this was helpful to you. If it was, remember to subscribe to the video, click on the bell so you're notified about new videos, and go to forum.drvax.com and you can discuss this video, this technique, FreeCAD, your experiences with hundreds of other viewers of these videos, all completely free. The forum.drvax.com is a discussion environment for the Dr. Vax community, where our goal is to continue to all learn together. Thanks again. Have a great day.